All right, folks, it's back in action here. In this video, we are going to go through just the very basics of some vector vocabulary. In the following videos, we're going to go through more work with how to work with vectors and how they can be useful for us. So let's just start off here up at the top, and we're going to look at what is a vector. So a vector is a quantity that has both a magnitude and a direction. Now, they're going to be denoted geometrically as array. Now, it's going to be slightly different than our arrays from geometry. They will have an initial point, but our vectors will actually also have a terminal point. So normally array goes on forever in a single direction, but our arrays are actually going to have a start and a stop, but they're going to look like array. So you can see like we'll have a terminal point and the arrow tells us the direction, and then it has a stopping point. Okay, the magnitude is actually going to be represented by the length, and that's a pretty important word for us here. It's going to be the length of the arrow, and that length is going to be the same as our good old distance formula. So when you see length, think distance. Now, the direction is going to be represented by that arrow, and that's going to be important to us as well. Vectors are commonly used to represent, let's say, aircraft speed. That's pretty common. We're not going to do a lot of the applications in this course, but there are many applications for vectors, okay? So our arrow is going to tell us the direction of the movement, and the length of the arrow would represent the speed. So if we want to make some little notes over here, let's just give ourselves some reminders. We're going to have an initial point. These would be, for example, initial points right there. And then these would be terminal points. Okay, basically at the ends of the arrows is where you're going to find those terminal points. Now, what we're going to find is there will be some vectors that are going to be, in fact, the same size. We will call those equal vectors, okay? Equal vectors, we're going to use just these printed lowercase letters. For example, we would say V is equal to W. So equal vectors will have the same magnitude, meaning they're going to be the same length, okay? Remember, magnitude is just a length. Okay, they're going to have the same length and direction, even if they have different initial points. Okay, so they might start in a different place, but they're going to have the same length and the same direction. Now, a zero vector is going to have a magnitude or a length of 0. Yes, it will just look like a point, and it will not be assigned any kind of direction. Okay, we're not going to really work with zero vectors too much, but it does exist. Now, vectors can actually be added, subtracted, and multiplied, and we're going to do these in the following pages. So we're going to say that we can add them. They can be added. They can be subtracted. And they can be multiplied. Okay. So all of those things can happen. Now, I personally find these images to be a little bit confusing, especially this addition one. So I think these addition ones can be kind of confusing. The one that I really do want to draw your attention to would be, let's say, this inverse one. This one I think is important. So if we had a vector that went this direction, if we wanted the negative of that vector, instead of thinking that we're going to go up 3 and over 4, we could also think of it as over 4 and up 3. We're going to reverse both of those. We're going to go down 3 and back 4. So if we're doing this inverse, this minus of a vector, we flip both values, both the vertical and the horizontal, to move from the initial point to the final point. Scalars, we're going to show, these are just going to double that length, and we're going to see how those work here in just a little bit on the next page. But a scalar multiple will only have a magnitude. But don't worry too much about these particular images, because we're going to work with these in the next page, and it'll make more sense with some examples. Except for this inverse one, I think this is an important one to draw your attention to.